Yeah, welcome to this Unit 5 of Measurement and Metrology subject. In this, we are going to study about some forces, and the forces are converted here into electrical signals. So, forces can be read by the instruments. We have to develop some instruments for the force reading. Obviously, we have some pressures, manometers, pressure gauges, dial gauges, which are measuring the forces and pressures also. And some depth of the subject is given in this unit 5, so we'll see that one. The first question I will take my here. So define what is the measurement of forces. What is the measurement of forces is here the force is measured to determine load acting on a body. So any load which is acting on a body is called force. Any any load on the body is called as force. It is also called as weight, measured by different directions, direct method and also indirect method. Means direct method is by touching it, indirect method by using sensors without touching it. Direct methods use comparisons with the standard weights. Some standard weight is there. Now whatever you are measuring, that weight is compared with the standard, that is direct method. So here elastic methods use deformation principles. So elastic methods means some rubber type elastic springs are used. If they are deforming, the deformation is read by this displayed in the display, which is also called as the force measurement. So force is shown in the form of displacements or standard value and comparison value, both are compared. They are direct methods. This is indirect methods, important in the mechanical testing ways. So here also you having a pendulum. Here counterweights are there. Some weight is given there. So some weight is this is a already known weight. This is unknown weight. So it is attached here. Now this pendulum will come down. The steel plate is here. This steel plate is here. So when it is coming down, so the difference value is read by this rack and pinion system. This is a rack and this is a pinion system. Some readings are made through by using these threads. Already I have told how the threads are designed, pitch, addendum, dedendum, the subject in depth. Now directly we are using this gear and rack and pinion. So this roller is there, which is rolling on this vertical bar. It is measuring some readings which are read by this pointer. This pointer is pointing in a dial. This dial reads the values. So this is a direct method, one of this one, because already you are using here counter weights are there, fixed rigid system is there, some fixed is there. One side you are having a fixed counterweights and here new weight is added. So the difference is measured by using this rack and pinion system, which is displayed in this system in the display, which is a pendulum scale. First one is. So define what is a direct method. A direct method, how to measure is analytical and platform balances. So analytical balance measures small forces accurately. Very small forces can be uh, measured by analytical forces. Platform balance measures larger loads. If you want to give large loads, platform balance, you can see in the platform buses, railway tracks, they are large loads. They can measure vehicles also. But analytical are small only. Like in golden shops, you can see 1 gram, 2 gram gold is measured. That is analytical. Platform is very high based on comparison with known weights only. Here also they are having some known weights. Now what is the weight you putting, the difference value is shown here. Simple and readable method, you can just read it, and they are also simple to start and stop, used in laboratories and industries. So this is generally you see in the gold shops. My some is here, some weight is kept here, this will be read here. This is a platform. You can put some heavy weights, larger weights can be measured. If I'm not wrong, coming to your third question, define what is elastic members. So the elastic members is nothing but loads, cantilevers, proving rings are there. So elastic members they are called as. So this is the load cells convert force into electrical signals. So as I told you in the first question, only force can be converted into electrical signals also. Cantilever beam deflects under load. If cantilever beam is one side fixed, other side free, then you can measure the deflection. Proving rings measure force by deformation. So this ring gets deflected inside or outside. The shape of this circle will be deformed. The deformation is measured here. So here force is applied from here up and down. A point, B point, force is applied. Here there is a sensor, which is it is a displacement sensor. This circular ring is there. This circular ring is there. Now what happens? This circular will either it will expand or it will contract. That will be read by this sensor. It is displayed in the displayed sensor. So ring and ring type. This is, as you are telling, this is a proving ring type. So this is a piezoelectric force sensors. So force is applied here. So when force is applied here, what is happening? It is taking the impact cap. This impact cap is housed in a housing, which is connected to an amplifier here. So there is some quartz element is used here and here. Now this will damp and this will damp and this will touch this area. So this will amplified and this will be displayed here. Okay. So this is a mounting stud. This is a preloaded stud. So this will come on down like spring system. When it is coming and touching, this is converted into electrical signals. Piezoelectric means already we have told the piezoelectric force system. So this amplifier is showing the values here. This is cantilever type. One side it is clamped, other side free. The length of this is L. It is unloaded beam, straight beam. When it is loading, it is coming down by y direction. Now y direction, the deflection is measured. How much deflection is there? Now that is the weight of this one. Our force is applied on this deflection point. If I am not wrong, I am taking the fourth question. Define what is measurement of the torque. So what is torque? Torque is the turning force on the shaft. So a shaft is broken by torsion force only. Now it is developing torque also. Measured using dynamometers. Some dynamometers are used for using the torque. Power and torque almost torque increases, power also increases. So they are interrelated terms. Mainly used for mechanical dynamic loading. You can do in the thermal labs most of this one in mechanical subject. It is measured during dynamometers. Important in engines and big machines. It can be used measured statically and dynamic. Some static loading or dynamic loading, both are measured. Ensures proper performances. So here you are having this type of mechanical torsion meter. This is mechanical. This shaft is there. This shaft is having inside flanges are arranged. This is flanges. This is flanges. One is a driven side. This is a driving side. So this is driving and this is driving. So this is rotating like this. Shaft is rotating inside. When shaft is rotating, here drum with a torque calibrated scale, drum on which pointer is fixed. This is fixed. This is rotating. Now this tachometer is used. How much of rotations are made? So they will be read by this turboscope. This turboscope. So one side is fixed. One side is rotation. This shaft rotates this one, and it is calibrated by this tachometer, turboscope for this torque readings. So here it measures dynamometers. Turning force is measured. Can be statically and dynamically by this meter is used here. So next question, torsion bar dynamometer. Generally torsion bar dynamometer is it is a bar type. So here you can see this is uses a twist in a shaft to measure the torque. The twisting of the shaft is done to measure the torque. It is based on the torsion principle. It is also measures angular deformation. Some angular deformation is made here. How much angle is that is read. Suitable for rotating systems only. Only this is rotating systems here. And also it is simple in construction. So here you can see this is the weight is given here. One arm is there. So this is torque is called as T is equal to W into L. So this W, how much of loading is done, this length T W L, that is Fr. This are called as brake blocks here. So here inside there is one pulley here. This pulley is here rotating pulley. The force is read here. How much of force is there? So this is a torsion bar ma, torsion and bar. This is a torsion and bar type material. So what you are going to, how much of angle this is displaced, this angle is shown here by using this pulley. So define what is servo control dynamometer. Generally, servo control dynamometers, servo motors uses feedback control system, maintains constant speed, also maintain constant load, high accuracy used in the engine testing, provides automatic control. So this is a dynamometer, servo dynamometer. One side engine is there, one side tachometer is there. So it is a tachometer is noting a number of turns. This one, this dynamometer is attached to one side here. This is a tachometer is attached to one side. Okay, so this is the values are measured here, because this is having some circuit type of connections. You see, engine is connected here, and also dynamometer. This tachometer is connected. So torque and speed are measured. Both the torque and speed both are measured under actual conditions. Engine speed and torque is controlled by the two-way feedback system. Some feedback system is also there here. Actual speed of the dynamometer is compared with the desired values. So what is the speed of the dynamometer compared with standards? If values are not equal, dynamometer control is automatically adjusted values. So it will adjust and it will take the values. So this is one dynamometer. This dynamometer is having a actual torque here. One side it is attached to engine. Now one side it is attached to tachometer generator. So this is making a circuit, and this circuit is displayed here. We can also measure torque and also speed here. This is a servo control dynamometer. So this dynamometer is servo control. That is a servo control. What is a defined absorption dynamometer? How this absorption dynamometer means absorbs power developed by the machine. So whatever the power is developed by the machine, this dynamometer will absorb. This converts the energy into heat. The energy is converted into heat, measures torque indirectly. So it will not touch, it will measure indirectly form only. Types include hydraulic and friction. So the hydraulic is like water or anything is used. Friction is used in the testing engines. So here you can see this is the strain gauges are attached here. This is a beam. Here also you have this input shaft. This is the output shaft. This input shaft and output shaft. So here strain gauge is attached. This strain gauge will convert this energy into heat. This input and output here. So it converts energy into heat, measures torque indirectly. So it is hydraulic and friction type. So hydraulic is used. Absorption means some beam is here. The beam is touching this strain gauge. This strain gauges will read what is this energy and heat developed inside this one. Eighth question: measurement of pressures. Generally, measurement of pressures is force per unit area. But the definition for this is force per unit area. They measured using variation instruments. So various types of instruments are there, but simple you can see in the market. Important in fluids and gases. So fluids are entering, gases are entering, their forces are measured. Requires calibration with standards. So you have to calibrate with the standard values used in many engineering problems. So here you can measure this gas. This gas is coming from this inside. So this will how much gas is coming, putting force, that much dials are passing here. That readings are noted here. That is a simple way of measuring this pressure gauge. 1 bar is equal to 100 kp. So this is a simple measuring pressure measurement. So ninth question, think define what is standard and calibrations. So standards and calibrations means some standard values are there. You have to compare with that. Pressure standards ensure accuracy. So pressures where you are using, they have accuracy. Instruments compared with standard deviations. Devices. Calibration reduces errors. By using the calibrations, number of times the errors are reduced. Done periodically, essential for readability. This is National Institute, National Metrological Institute in national level. It is giving a accreditation. That accreditation is given for all these one in-house calibrated laboratories, working standards, and also measuring equipments used by companies. So 10th question you can see basic pressure. Define what is basic pressure measurement methods. In this basic measurement methods based on the liquid columns, liquid rise is there. That liquid is manometers. Elastic deformation. We have seen many electric deformations. Based on the electrical transistors also you have seen there electrical transistors, some of this The changes in the electrical transducers you have seen. Selection depends on range. How much range is that will be used in different applications. So this is generally here you are going to put the gas or liquid or fluid. So here this makes a difference and it will read the readings here. That's the generally manometer or elastic deformation does. The 11th question is what is dead weight causes? So dead weight causes is also, so you have to measure the dead weight. Primary standard for pressures uses known weights on the piston. Once that piston is there, that piston is having this pressures, produces accurate pressures used for calibration high pressure instruments. So here, air bonds on weights and pistons. So this is already there is some liquid is filled here. This liquid is filled now. A weight is kept here on this one. So this weight is coming down and pushing the liquid here. Okay, from this also you are pushing the liquid here. Here also you are putting. So what is happening? The difference is measured here. Okay, this before it is full. After that it is how much difference. This is measured in this gauge. So you put a weight. You put a weight on this liquid. This liquid will give you the difference of this two columns. These two columns are read here in the gauge. So this is a dead weight system. Generally used for lift systems also. Lifts also generally while working here. Define what is manometer. Manometer is also same. Manometer is pressures liquid columns. So pressure of a liquid is measured because you can't say pressure, but liquid movement you can measure. YouTube incline manometers, they are simple and accurate. Used for low pressures also based on the hydraulic principles. So this is a enlarged leg manometer. So here some floating is there. This floating is attached to a dialer. From here you are giving pressure P2. From here you are applying some air inside. Here also air separate. Then what happens? The height of this is measured here. The height of this is measured. How much height is there? Yeah, this pointed here in the pointer. That is reached manometers generally. You can see here. Also, 13th question you can see here. Define what is high and low pressures manometers. So generally, this is the atmospheric pressure line. Above this, it is called as a absolute pressure, a high pressure. Below this atmospheric line, it is called as vacuum pressures. So this is absolute zero pressure. So absolute zero pressure plus vacuum gives you atmospheric line. Atmospheric line plus this gauge pressure gives you absolute pressure. So from here 0 to height absolute pressure. From 0 to this one vacuum pressure. This is a vacuum pressure starts here and travels up to this atmospheric pressure. So from atmospheric it starts with the air. This is the absolute pressure. Pressure is taken on the y-axis. Absolute zero pressure is taken here. So last question, I think 14th question, you can see what is a elastic transducer. So here my elastic transducers works on deformation principle. Example, Bourdon tube, diaphragm, pillows. This is a Bourdon tube. This Bourdon tube is a converts pressure into displacement. Any pressure is coming inside this tube, it is filling. So it will expand or it will contract. That will be read by this attached here. It will dial is running. This dial will run this pointer and scales are made here. This scale will show his. This is the how to measure the pressures into displacement. So this tube is filled with the air. This air will make some dial rotate. This dial is pointed here. This scale is showed. This is so this can bend or it can contract or it can expand. Both things this elastic transducer do. That readings are noted here. So this is a Bourdon tube generally shown here. Some diaphragm is used. This is the diaphragm is used. Some billows is used here. So highly reliable, used, widely used in the industries. These are generally used. So 14 questions I have covered basic knowledge, elastic transducers, pressure measurement, manometers, dead weight which is used for lifts. This dead weight is kept on the liquid. This liquid is read. It is so this is generally a dial gauge which is reading the pressures. We are having some standard calibrations. This is generally a what I told you inside the gas or liquid it will measure. measurement. This is also somewhat absorption dynamometer. This absorption dynameters. Shafts you are going to measure. This is a servo dynamometer, servo control dynamometer. Servo is used. This is arm type torsion bar. Torsion bar is used here. This is a measurement of torque. This is measurement of torque on the shafts, totally shafts. These are the three types of basic elastic transducers I have told you. There is change in the shape they are read. Largely platforms, big vehicle, big weights are small weights measured here, direct method, and also the measurement of forces. So completely the forces are nothing but the acting loads. They are direct, indirect. Direct are compared with the standard values, indirect are deformation values are taken. So these plays important questions I have covered. Fifth unit, I hope you will be updated with your knowledge in the mechanical engineering of the metallurgy and measurement. And, any suggestions, please give. And thank you. Thank you for watching these videos. Like and share it. Thank you, ma.